Hello everyone. Welcome to my channel Chemistry by ANR. Today we are going to discuss about diazonium salts. Diazonium salts are an important intermediate for almost all of the organic conversions. We can prepare n number of compounds starting from either benzene or nitrobenzene or maybe aniline and come up to a diazonium salt, and preferably benzene diazonium salt, in order to obtain other important organic compounds. We need to keep in mind that benzene diazonium salt is resonance stabilized, whereas aliphatic diazonium salts, they are unstable and they give alcohol as the final product. So let us explore some new concepts. Hello everyone, welcome to my channel Chemistry by ANR. The topic is diazonium salt. Now diazo is what linkage? It is N2 plus linkage. Diazo linkage is N2 plus linkage. This R N2 plus X minus is from aliphatic. Why? Because there is an alkyl group attached to it. So it is aliphatic. Now, R stands for an alkyl group, not aryl group. It stands for an alkyl group. Now, if I write AR N2 plus X minus, then this AR will stand for aryl group or benzene diazonium chloride. I can also write C6H5 N2 plus Cl minus for chloride, X minus for halide. Now this X minus ion can be Cl minus, Br minus, HSO4 minus, BF4 minus, etc. But the most widely used is benzene diazonium chloride. Now these N2 plus linkage, if this N2 plus linkage is attached with the benzene ring or aryl ring, it's named as benzene diazonium halide or chloride, specifically for Cl minus. Just now I have mentioned it. Now, primary aliphatic amines. Primary aliphatic amines, by that what can we say? I can say RNH2, because the nitrogen atom is directly attached to one carbon atom, so it is primary, and it is attached to an aryl system, so it is aliphatic. So primary aliphatic amine forms unstable alkyl diazonium salt. So this is an intermediate. Now this intermediate is unstable. This intermediate is unstable, and this point is very important to remember, that the one which is obtained from aliphatic is unstable. So primary aliphatic amines, they produce alkyl diazonium salt by diazotization, but it is unstable. Whereas primary aromatic amine, they form benzene or arene diazonium salt. So if I say that it is aromatic, then it will form arene diazonium salt, which is resonance stabilized. It is stable. Why it is stable? On account of resonance. The stability is explained on account of resonance. Please note that the nitrogen is having a positive charge which is directly attached to the aromatic ring, for which it is getting the pi cloud towards it. So I can say this is the minus R effect that is taking place, for which there occurs a positive charge in the ortho position, next in the para position, and next in the ortho position. So we can see here, first in ortho, then in para, and again then in the ortho position. So these are the resonating forms for which it is resonance stabilized, and for which the arene diazonium ion has an extra stability. It is an important intermediate for all aromatic, almost all, I will say, conversions. It is an important intermediate. Now, how to reach this benzene diazonium halide or chloride? The method is known as diazotization. That is the reaction by which I can obtain this benzene diazonium halide or diazonium salt. If it is aliphatic, then also it is a diazonium salt. Only the difference is it is alkyl system, otherwise it is aryl system. So here the temperature and pressure condition is ought to be remembered. So please keep in mind that this is aniline. C6H5NH2 is aniline. I can start this reaction. Starting with aniline, I end up to this benzene diazonium chloride by adding aqueous NaNO2. Do remember it in this manner, plus dilute HCl. So, if you give aqueous NaNO2 and dilute HCl, it produces in situ HNO2, which is known as nitrous acid. So, it is forming HNO2 in situ. And please do remember that the temperature condition is 0 to 5 degrees Celsius, hence 273 to 278 Kelvin is mentioned. So this condition needs to be remembered very, very nicely, that aqueous NaNO2 dilute HCl 0 to 5 degree Celsius. So this reaction is known as diazotization reaction. Now, in case you are not given aniline as the starting material and your starting material is benzene, yet I can end up to the diazonium salt by converting it to nitrobenzene using concentrated HNO3 and concentrated H2SO4 nitrating mixture, and I will get nitric acid. Now nitrobenzene. So when I get nitrobenzene, when I reduce it by the reduction of nitrobenzene, I can use SN plus HCl, or I can use Fe plus HCl, and I can get aniline. And from aniline, I can actually produce what? Benzene diazonium halide or chloride. If I use HCl, obviously I will get halide, which is Cl. Next, the physical properties of benzene diazonium chlorides. They are what? They are colorless crystalline solid. They are soluble in water because of the polar nature. It is having a positive and the negative charge over it. So it is it is having a polar nature, and so it is soluble in water. It is highly stable due to resonance, so stable in cold, but it reacts with water. Yes, when warmed, and it forms what? It forms phenol. We are going to see all these reactions later on. Now, benzene diazonium fluoroborate, okay, this HBF4, if it is getting attached, is water insoluble and is stable at room temperature. So let us see how we can obtain other products from the benzene diazonium halide intermediate by the method of diazotization from aniline. So we can obtain chlorobenzene, bromobenzene, cyanobenzene. These all things we can obtain by a reaction which is known as Sandmeyer's reaction using Cu2x2 in presence of HX, where X can be equal to Cl or Br. So we can obtain chlorobenzene or bromobenzene. Remember, the important side product is N2 gas in each case. We can also use CuCN, KCN in order to obtain ArCN. Now, there are other methods also like Gattermann reaction, where we can use Cu and HX, where X is preferably Cl or Br, in order to obtain ArCl and ArBr. Now, the side products are not only N2, along with that the side products are CuX. That means it can be CuCl, or it can be CuBr. You can see with state of copper it is actually +1 state. Now, the two methods of obtaining chlorobenzene and bromobenzene are Sandmeyer and Gattermann. So what did we see just now? We have seen that from benzene, from benzene, we can obtain nitrobenzene by the method of nitration. Concentrated HNO3 and concentrated H2SO4, and you can obtain nitrobenzene. This nitrobenzene, you can undergo reduction using SnHCl, or you can use FeHCl, and you can obtain aniline. And aniline can be the starting or rather substrate starting substance in order to obtain what? In order to obtain benzene diazonium halide by diazotization reaction. So I can use aqueous NaNO2, and I can use HCl, dilute HCl, and keeping the temperature 0 to 5 degrees Celsius, and I can get benzene diazonium chloride. So this is your benzene diazonium chloride. So I can just write N2 plus X minus if I use HX. Okay, so this is the important intermediate. Now let us see how we can obtain chlorobenzene, bromobenzene. Over here in Sandmeyer reaction, just now we have seen Cu2X2 and HX. So I can use Cu2X2 in presence of HX, where X can be Cl or Br, in order to obtain chlorobenzene or bromobenzene, and it is X over here. Remember, the important side product was N2. Now, Sandmeyer reaction also include the reaction with CuCN and KCN. So I can use CuCN in presence of KCN in order to obtain cyanobenzene. So this is CN. These two reactions are Sandmeyer's reaction. They are Sandmeyer's reaction. Okay, so now there is Gattermann reaction, which is what? Gattermann reaction over here, it is Cu and HX. Okay, so again I am forming the flow chart over here. Always practice in this manner in order to remember in a better way. Cu and HX, where X is equal to Cl or Br. Maybe that again I will get chlorobenzene, bromobenzene, but the name of the reaction is different. So this reaction will be giving you again chlorobenzene, bromobenzene, but this is known as Gattermann reaction. So they are important as name reaction. Next, let us see. If I give Ki, when I give Ki, I will get iodobenzene. The side products are KCl and N2. So chlorobenzene, bromobenzene is obtained in this method. Now, if I give Ki, then I will get iodobenzene. Okay, so chlorobenzene, bromobenzene, iodobenzene is sorted. So next, let us see. If we give HbF4, okay, it is treated with fluoroboric acid, then we are going to get, on heating, we will get fluorobenzene. Okay, so if we give HbF4 and we heat it, then we will get fluorobenzene. So HbF4 and heat will give fluorobenzene. So this is the fluorobenzene. So these are the halides which we have seen. Aryl halide, chlorobenzene, bromobenzene. We have got cyanobenzene. We have got fluorobenzene and iodobenzene. Next, if we give H3PO2 and H2O, okay, so it's known as hypophosphorus acid, or we give ETOH or ethanol, then it gets reduced to ARH, means what? It means benzene. So I can say that H3PO2, over here I can give H3PO2 plus H2O. Okay, or I can just say H3PO2, or I will say ethanol, C2H5OH. Okay, then I will get benzene. So isn't it so much of fun that you are starting with benzene, you are going to nitrobenzene, going to aniline, going to I'll say diazonium, and again coming back to benzene in this method. Okay, apart from this, we can also obtain phenol. Just see, you can obtain phenol over here. This is phenol. AROH is phenol. Just by adding warm water, you can obtain phenol by this method. Okay, so here I can just give warm water, warm H2O, and I will get phenol. So this is phenol. Now, next what we can get? We can even get nitrobenzene. You are starting with nitrobenzene. You are getting nitrobenzene again. What will you do? You are going to add HbF4, number 1. Number 2, Na2 and Cu heat. Okay, so when you give HbF4, NaNO2 and Cu heat, so this is it. HbF4, number 1 is HbF4, number 2 is aqueous NaNO2 also you can write, and what? Cu comma heat, you will get, here you can give slash. Now here slash doesn't mean or. You will just write or if you think you want to use any alternative pathway. Now this slash means along with Cu, and you are getting nitrobenzene. Now, if you just give HbF4, you are going to get this compound with N2 plus and BF4 minus. When you are just giving what? HbF4, you are getting diazonium fluoroborate. The name is diazonium fluoroborate, and when you heat it with aqueous NaNO2 and in presence of copper, so do add over here AQ NaNO2 in presence of copper, you will get what? Nitrobenzene. So this is your flow chart. You can do it for yourself. You can keep it for yourself. It will be easier for you to summarize the concept and study. Next is diazonium coupling reaction. This particular reaction is very, very important for your practicals, for your board practicals, where you do the confirmatory test for phenolic OH, you do it for phenolic OH, you do it for amino group, you do the confirmatory test. For phenolic OH, what you do, it is known as azo dye test. You can see the azo products obtained have an extended conjugated system. Okay, that means extended means it is over long distance, and conjugation means alternate arrangement of single bond and double bond. And this compound is thus colored, and they are used as dyes. Why? Because they have an extended conjugated system. Now in this reaction, we can see that this is your benzene diazonium, left hand side benzene diazonium chloride. There is just elimination of HCl, and there is a combination of this nitrogen chemical bonding and this carbon gets a covalent linkage. So N double bonded N linkage is the azo linkage. Okay, so this is obtained, an orange dye is obtained when you use phenol. See, the medium is basic medium, but for aniline the medium is acidic medium. Do you know why it is so? Because phenols are acidic in nature, so it dissolves in this basic medium, and aniline is basic in nature, and so it dissolves in this acidic medium. And what you obtained is a yellow dye for aniline and orange dye for phenol, and this can be used as a distinguishing test for phenol and for aniline, and this is an example of electrophilic substitution reaction. So we wind up the class, we wind up the session. Till this, thank you all of you.